Okay, this is topic 2, which is equations of circles. Okay, and this one's a little shorter. The standard form for the equation of a circle in the coordinate plane is x minus h squared plus y minus k squared equals r squared. Some of you guys asked why that is, and it's a really good question. It's not necessary for you to write anything on this, but just to kind of watch if you want to, or if you don't care, you can scroll past this part. But if you have a circle, let's say your circle looks like this, just for simplistic purposes. Okay, and then our circle center is here. So any point on the circle, if I wanted to figure out what the length of this was, I would do, this would be the radius, I make a triangle. A would be my distance horizontally between the 2 points. B would be my distance vertically between the 2 points. So the length of this, if I didn't know what these points were, well, if I know the center, so the center is at 2, 1. I would do this point x, y, which could be any point on the circle. Even if it was over here, it'd still have a and b and then r. So I would do Pythagorean Theorem, x minus 2 squared. So I'd do x2 minus x1 squared plus y2 minus y1 squared equals the radius, which we don't know it, but it's going to be squared. We do know the radius, it's 2 in this case, because the radius, this length is the same as this length, which is 2 units straight up. So it's going to be 2 squared, but that's going to give me 4 in the formula. But always when we're using the Pythagorean Theorem, c is also squared, so that's why the radius gets squared in this formula. So that's where the formula comes from. And so notice that this center is driving the formula, but a lot of different points satisfy this equation. So if I put in 4, because if that was the radius squared, the radius was 2 squared. So if I do that, let's say this point, for instance, is 0, 1. If I plug in a 0 and I plug in a 1 here, I get 0 minus 2, so that's negative 2 squared, which is 4. And then 1 minus 1 is 0, so 4 equals 4, and it checks out. So that's a point on the circle. If I plugged in this point, 2, negative 1, 2 minus 2 is 0. Negative 1 minus 1 would be negative 2 squared, which is 4. And that would equal 4, so that checks out. So a lot of things are satisfying the x and y. It can be anything along this circle. But that's where the equation comes from, if you care. If not, important thing to remember is that HK is the center of the circle. So those two letters represent the center points of the center x and center y of the circle. And R is the radius. Okay, notice in the formula this is a minus h, and then in the actual center this is a positive h. That means that these two things are different signs. So in the equation, if it's a positive here, the center is actually going to be a negative 4. In the equation, if this is, these are opposite signs as well. So if this is a negative in the equation, it's a positive as the center. And then the radius, this is the radius squared because this is c squared of the formula essentially, so radius squared. To get the radius, you would take the square root of both sides, so r is equal to 5. Okay. So again, just to get the center and the radius, you just change the sign, square root. So the center would be 7. Y plus 0 is just going to be 0. 0 negative, you don't need to write negative 0. It still doesn't have any value. And then the square root of 4, so 4 is r squared, so r is going to be, you take the square root of both sides, 2. Okay. So these are just changing the signs and square rooting this. And then to graph it, because I do want you to graph it, it says to graph the center, you would plot the point at the center. Okay, that's my center. And then my radius is 5. So that means I'm going to go 5 units away from this point in every direction. Okay, that's the center. I'm just going to circle so I know. Okay, so those are 5 units away from this center point. And then I connect those in a circle as best I can. It doesn't have to be perfect. Okay. It's pretty terrible, but that would be the circle sketch. Okay, on this one, 7, 0 was my center. I'm going to go 2 units away in every direction. So 2 units right, 2 units up, 2 units left, 2 units down. And connect those as best I can. And that would be my circle equation. So I'll let you try 3 and 4. But again, to identify the center, you just change these signs and square root this to find the radius. Because the formula is radius squared, so the radius itself is the square root of this. Okay, numbers 5 through 12 is very similar, but you don't have to graph it. So you're identifying the center, so that part should be very quick for all of these. So you're just changing the signs here. So this is a minus 5, which means it's going to be 5. And this is a minus 1, so it's going to be 5, 1. The 64 is equal to r squared, so the radius, if we square root both sides, is just 8. Then some of them ask for the diameter. So the diameter, the radius, remember, is 8 on, let's say, number 5. The diameter would be 16. The diameter is all the way across. So if you can get the radius like you've been doing, then you can just times it by 2 to get the diameter. So the center for this one, if there's nothing written by the x, it's just 0. 42.25 is the radius squared. That's the part of the formula. So to get r by itself, we would square root both sides and get 6.5 is the radius. Okay, so if 6.5 is the radius, that means the diameter is twice as big, so 13. Okay, circumference is going to give us, they want to know if you were to walk around this, how much would it be if you know the radius? Well, remember from the previous lesson that the radius is part of the circumference formula, so you still need to get the radius. And then once you get the radius, you just plug it into the circumference formula, and you're done. So the center, again, you're just grabbing it opposite signs from this part of the formula. 196 is r squared, so if we square root both sides, r is going to be 14. Well, the circumference has r in it. It's 2 pi r. If r is 14, we plug in 14 for r. And 2 pi 14 really is 28 pi. Okay, you can multiply them in any order. Okay, and then area. Well, the center for this is going to be 3, negative 4. Area is really nice because this is r squared. And area formula has r squared in it. So you just take this number and substitute it in for r squared. So it's 81 pi. Okay, so you don't need to square root or anything for area. You just take the number here, that's r squared, plug it into the area formula, and just multiply it basically by pi. Okay. General form of an equation of a circle is going to be ax squared plus by squared plus cx plus dy plus e equals 0. So they may give you equations in this format. If they do, then we want to complete the square, which is something that you learned in Algebra 1, to get it into standard form, which is this form, because this form is easy for us to tell the center, this form is not. So the steps are below. First, we're going to group the x terms together and the y terms together, and I would say here leave a space. So you're going to group the x terms together, which we have these two, no other x terms, and then we're going to leave a space. And then we group the y terms together and leave a space. And we want to move the constant to the right side of the equation. So in order to do that, you have to inverse operation, so add 6 to both sides. And this actually also has a dash underneath. So we're going to complete the square, which means we're going to take half of the linear term, which is the x value. So we take half of this. If it's negative, then half of that is going to be a negative number. If it's positive, half of that is going to be a positive number. So half of 2 is negative 1. Negative 2 is negative 1. Half of 6 is positive 3. And then we square it and add it to the equation. So we square negative 1, and that's 1. We square 3, and that's 9. Okay. So we do that for x and for y. And I did steps 2 and 3 really in the same level. Okay, and if we've added 1 and 9 to the left side of the equation, in order to keep it balanced, we have to add 1 and 9 to the right side of the equation, or else the left side of the equation is now 10 units more than the right side, and it's not equal. So in order for this equal sign to remain, we have to add what we added over here, over here. Okay, this trinomial is the same as this binomial squared. So if I were to factor out x minus 1 squared, and I'll just show you that it does equal this. That's the whole point of getting the square here. So if we do x minus 1 times x minus 1, that's what x minus 1 squared means. We have to FOIL this out. So we'd have x times x, and then x times negative 1. And then we do negative 1 times x, and negative 1 times negative 1. So that equals x squared minus 2x plus 1, which is what we have here. So these two things match, which means I can rewrite this as x minus 1 squared. So that's the only reason I'm able to write it like this, is because I have the whole trinomial, if I were to factor it out, what it looks like. So that's why the plus 1 is essential, and it needs to stay on this side, and we have to add it to this side in order to keep balance. This one, same thing. It's going to be y minus 3, and I could plus 3. Whatever sign's here, it's going to be here. I could show you that y plus 3, if I were to FOIL that out, it would give me this. So that's how come I'm able to write this, because I had this whole trinomial, which is what this is equivalent to. And then 6 plus 1 and 9 equals 16, so that's what it turns into. Now it's in standard form, which is what we want, because standard form allows us to identify the center pretty easily and the radius. So remember, this is radius squared. We square root it. These, we just change the signs. Okay, and that's the method to completing the square. So there's 6 problems for you to practice. I'll do one more with you. We'll do this one because it's got some things on both sides. So if I skip down to 16, my first step is to get all my x terms together on the same side. Right now, this 18 is on the incorrect side, so I need to move it over here. It doesn't have a like term, so I'm not kind of putting it underneath anything in particular. Just kind of off by itself. But to move it over, basically you change the sign to move something over to the other side. And then we already have y's on the correct side, and the negative 62 is on the correct side. So all we really needed to move was this x term was on the wrong side. Then we take half of this number, so it's a negative 18, so negative 9, and we square it. This is a negative 2, so negative 1 is half, and we square it. So we're going to be adding 81 and adding 1, which is the square of these. Okay, so then when we do that, we get x minus 9, so whatever this number is, that's what comes in your parentheses, and y minus 1. And then whatever negative 62 plus 81 plus 1 is, so 20. Okay, so the center would be 9, 1, and the radius would be the square root of 20, so we take the square root of this. Well, we want the diameter, so we need to times that by 2. Okay, and you typically don't see the square root of 20 left like that because it's got a perfect square in it. So that becomes 4 radical 5, and the 4 turns into a 2 outside, so it'd be 4 radical 5 and 9, 1. Hopefully that made sense. I'm going to go ahead and just flash these answers for the circles part so you can check your work. It's okay if you got this answer in decimal format. I don't care about if it's decimal or not, but or simplified fraction, but as long as you know how to do the process. I'm trying to consider if I should do one more. I'll do one more. If you don't need it, then don't use it, but if you do, here's just one more example. So I'm going to group all the x terms together. I have this 2x on the wrong side, but I have a like term with it this time. There's another 2x here. So this is going to become minus 4x space. I'm leaving the space so that I can complete the square. So remember, this is a different level. And then I have the y squared term, and the 10 is on the wrong side, so I need to move the 10y over and leave a space. And then the 20 is also on the wrong side, so a bunch of stuff on the wrong side. Okay, so I have the x squared, I had the y squared. I moved this 2x over, so it became negative 4x. I moved this 10y over, so it became positive 10y. And I moved this 20 over, so it became negative 20. So this is just rearranging the equation and getting it x's grouped together, y's grouped together, and then the constant by itself. Alright, so taking half of this, I get negative 2, and I want to square it. So I'm going to be adding 4. I take half of this, and I want to square it, so I'll be adding 25. So I have to add 4 and 25 on this side as well to keep it balanced. Okay, so it's going to become x minus 2 squared. So whatever this is, that's going to be in your parentheses, and y plus 5 squared. And then negative 20 plus 29 is just going to give me 9. So the center would be 2, negative 5, and the radius would be 3. So the circumference, which you do have to memorize the circumference and area formula because you kind of use them a lot. And plugging in that in, you get 6 pi. So 3 times 2 times pi is 6 pi, which is about 18.8. Okay, last topics. This is a review, pretty much. This side is. All of the directions for this set, this and the next side, are to write each equation, circle equation, in standard form with the given information. So please write these in standard form, the equation of the circle. Don't just stop if you get the radius or whatnot. Okay, so feel free to pause this. I'm going to write this in real quick. Pause this and copy it in. Okay, so they give you the center and the radius or the diameter. Let's see if you can figure it out. So in order to get the equation of the circle, you need the center and you need the radius. So the ones that give you the radius, you're set. If they give you the diameter, then you need to figure out what the radius is. So remember, the diameter is all the way across. The radius would be just half of that. Okay, even if it's a decimal, it doesn't matter. Just do the square root of 47, well, divided by 2. So about 3.42. Okay, so once you have the radiuses, then you're just plugging these into the formula. So let's just do this one. So I'll plug in x plus 4. So remember, I'm changing these signs because these two things are opposite signs. Y squared, because 0, you don't really write plus 0, equals, okay, that 47 number, when I square rooted it, that's the diameter. I had to divide that by 2 to get the radius, so that's the radius. In the formula, the radius is squared, so I would square this, and I get 11.75. If you round your answer, then this is going to be a rounded number, but if you don't, then it comes out exactly as 11.75. Alright, set 2 is if you're given the center and you're finding the circumference or area. So, or sorry, and given the circumference or area. So you still need to find the radius. All these you need to find the radius because, well, yeah. Because the radius is part of the formula and the center is part of the formula. Well, they already give you the center, so each of them is halfway there. You just need to get the radius. So if the circumference, which is 2 pi r, equals 6 pi, and we did this on the day 1 work, the radius is going to equal 3, because I have 2 times 3 is going to make my 6, and the pi's already match. Okay, or I'm just dividing by 2 pi if you want to actually see the math out. Okay, so the radius is 3 here. The radius here is going to be half of 17. Well, I'll let you figure it out. This one, the area is equal to pi r squared, so it's a different formula for area, don't forget. 16 pi is the area, so you would be dividing by pi to get r squared by itself. And because actually the formula has r squared in it, you can stop there. So if you want to get r squared for the area ones, that's probably better. So 16 is going to be the end of the equation. and 361 is going to be the end of the equation. All right. Then you're doing the center like you've been doing. So changing the signs of what's on there, and then squaring the radius. Changing the signs of what's on there, and this is already r squared, so we're good. So those are the answers. Okay, the third type is if you have a graph. What you would do with the graph is you would identify the center. You still always need to write the equation of the circle. You need the center and you need the radius. So if you can identify the center of the circle by just looking at it, if you can't do it by looking at it, then what you would do is look at the topmost point and the bottommost point. See how far away those are, and then go halfway. Okay, so this is 10 units away, so I go 5 units away. So that tells me the radius is 5 actually, and then this point is 3, negative 2, so the center would be 3, negative 2. Okay, then I'm doing what I did before, and writing the equation, which I'll let you write. Alright, back page. Okay, this time, for this site, we're given a center and a point on the circle. So again, anytime we need to write an equation of the circle, we need the center, we need the radius. We have the center, but we don't have the radius. So the radius is the length from the center to a point on the circle. And typically they give us this number like 11 centimeters or 11 feet or whatever. These problems, they don't give it to us, so we have to find it using the distance formula, which is x2 minus x1 squared and y2 minus y1 squared. Okay, or you can use the Pythagorean Theorem, but at this point, if you're not familiar with how to use the Pythagorean Theorem, then it's probably good to start memorizing the distance formula. And in the problem, I'll call this point 1. Doesn't matter which point's point 1, which one's 2, but you need to find the distance between them. So we're going to be using the formula, plugging in all of these subscripts. So alright, so it's going to be x2 minus x1, so 7 minus 9, and 4 minus 10. So negative 2 squared and negative 6 squared, which equals 4 and 36, so square root of 40. So that's the radius. Okay, so the length between the center and the point on the circle is the radius. So that's what we're finding here when we're finding the distance. Alright, so to write the equation of the circle, we just change the signs of the center. So that's this, changing these two signs. And then we square the radius. So if the radius is the square root of 40, and we square that, the square cancels with the radical, and we get 40 for the end of our equation. Okay. And then we do that again for these three. If you like the Pythagorean Theorem, you're basically doing this in your head. So A is how many units are between 2 and 1. B is how many units are between negative 6 and 10. So A is 1 unit, B is 16 units, and you're doing A squared plus B squared to get the radius. Writing the equation of the circle, you would change the signs for the center and square this, which comes out of the radical. Okay, and then the last type of these is they're giving you the endpoints of the diameter. So, but we need the center and we need the radius to write the equation. So to get the center, we're going to use the midpoint formula. So this is going to be helping us find center. This one's helping us find radius. Okay, so center, midpoint, which is x1 plus x2. It's the average of the x's and the average of the y's. So radius, diameter, sorry, radius, distance, center, midpoint. So if we do the midpoint, the middle of these two is going to be negative 14 plus negative 10 divided by 2, and 1 plus 9 divided by 2. On your calculator, if you type in 14 negative plus 10 negative and divide by 2, you're going to get the wrong answer because it's doing order operations and it's only dividing the 10 by 2. So what you want to do is you want to type in 14 negative plus 10 negative equals, so really this is in parentheses, and then you can divide by 2. So it's negative 12. And you want to make sure your answer is reasonable. Is negative 12 in the middle of negative 10 and negative 14? Yes, so that's the right midpoint. 1 and 9 in the middle of it. If you add them, 10 divided by 2, 5 is in the middle. So it's 4 units away from 9, 4 units away from 1. Okay, so that's the center. And then the radius, we just can pick either one of these points because we know the center now, so we just need like one point in the center and we can use the distance formula. So I'll just pick the negative 14, 1. And I need to find the radius using these. Okay, so you can pause it, plug those numbers in. Negative 14 minus negative 12 squared and 1 minus 5 squared. So this will be negative 2 squared and negative 4 squared, which equals 4 plus 36 of 40. We have 40 twice. Seems highly unlikely. Okay. Yeah. It should have been 20 for this one, so let's see, I did something. 4, and 16 is 20. Okay. I was like, not likely that we got the same thing twice. Okay. Alright, so that's the radius, so it's going to be the center was this, and this is the radius. So x plus 12, we change the signs. Y minus 5 equals square root of 20 squared is 20. And that's it for the second topic.